September 9, 1943. The Italian battleship Roma was underway in the Tyrrhenian Sea when two Fritz X guided bombs fell from high altitude and corrected their path toward her. No pilot rode them down. The Roma's crew had no warning of what was descending. Both weapons struck her armored deck in succession, detonated her forward ammunition magazine, and broke her back. 1,353 men were lost to a weapon directed by a bombardier sitting inside a different aircraft entirely. That moment was not unique to one nation or one theater. Across the Eastern Front, the Atlantic shipping lanes, the Pacific island chains, and the launch ramps of northern France, 5 major powers were each committed to the same question. Could destructive force reach a target without a man at the point of impact? Wire-guided carriers, radio-linked armor, glide bombs steered by radio signal, television-fed munitions, and weapons that navigated themselves. The methods varied, the trajectory did not. This is the story of how far that separation advanced before 1945 ended the war. Starting at number 10. Number 10, French 5 P9, The Wire. That started it all. In the opening months of the war, before the fall of Paris, before Dunkirk, France had already committed resources to a question most armies were still treating as experimental. Could a demolition charge drive itself to a target? The VP-9 was a remotely guided tracked vehicle, a small, low-profile carrier designed to deliver an explosive payload to a fixed position and detonate on command. The concept originated from French engineer Adolphe Caigres's prototype work on tracked vehicle guidance systems. Control was maintained through a trailing copper wire spool housed in the vehicle's rear chassis. As the VP-9 advanced, the wire paid out behind it, maintaining a live electrical connection back to the operator's control station. Steering was managed by modulating current to left and right drive motors independently. Braking, direction, and detonation all ran through that single wire link. The system had no autonomous capability. Every movement required deliberate operator input, and the controller remained stationary and exposed throughout the engagement. Operational use was limited by the speed of the French campaign itself. The VP-9 saw field trials but was overtaken by events before it could be deployed at scale. German forces advancing in the summer of 1940 captured documentation and hardware, and French engineering notes were later reviewed by German ordnance teams, developing their own wire-guided platforms. The VP-9's significance was not in battlefield performance. It had almost none. Its significance was in the principle it confirmed, that a wire-guided demolition carrier was technically feasible and that the operator could function from concealment while the weapon advanced. The system also confirmed something less encouraging. The wire was a constraint as much as a capability. It limited range to whatever the spool could carry. It exposed the operator's position along the line, running back across open ground. The weapon could travel no further than the cable allowed. It placed a human operator at the end of a wire rather than at the point of detonation. That boundary, once crossed, would not be walked back. Number 9 moved the same concept further and put it into mass production. Number 9, German Goliath tracked mine, the disposable machine. By 1942, German combat engineers needed a solution to a specific problem: how to deliver a substantial explosive charge into a fortified position, a tank formation, or a bridge structure without committing personnel to a one-way approach. The Goliath was that solution, a direct evolution of the captured French VP-9 designs and Adolphe Caigres's guidance principles. Produced in 2 variants, the electric SD-KFZ-302 and the petrol-engined SD-KFZ-303, the Goliath was a single-use tracked vehicle carrying between 60 and 100 kilograms of high explosive, guided by a 3-conductor cable connected back to a handheld joystick controller. The cable was also the system's primary vulnerability. As the Goliath advanced, wire paid out from a rear-mounted drum, giving the operator directional and speed control. When the vehicle reached its target, the operator triggered detonation from the controller. Allied troops in Normandy and Italy learned quickly that severing the cable rendered the Goliath inert. A single rifle shot to the wire ended the engagement. In several documented engagements during the Normandy campaign, infantry disabled Goliaths at range before they could close on their targets. Production totals reached approximately 4,500 units, enough to confirm this was a serious operational platform. Goliaths were deployed on the Eastern Front, in the suppression of the Warsaw Uprising, and in defensive positions across Western Europe. The Goliath was expendable by design. It was not recovered, repaired, or reused. It was consumed in the act of destruction. That operational philosophy, the single-use guided weapon, would recur throughout the rest of this countdown. Number 8 removed the wire entirely and gave the operator a radio link instead. Number 8. Soviet Teletank, the Armored Ghost. While Germany and France were developing wire-guided demolition carriers, the Soviet Union was working on something categorically more ambitious: a full-sized armored radio-controlled combat tank. The Teletank program began in the 1920s and reached operational maturity during the Winter War against Finland in 1939 and 1940. Control was transmitted from a standard T-26 or BT series command tank following at a distance of up to 1,500 meters. The Teletank received throttle, steering, braking, and weapons fire commands via encoded radio pulses. The system allowed an armored vehicle to advance into minefields, gun emplacements, and positions under direct fire without risking a crew. Flamethrower-equipped teletanks were used in Finland against bunker positions, while the command tank remained outside effective defensive range. The program documented both capability and limitation. Radio control at distance was viable for basic movement and weapon activation. Precision maneuvering across broken terrain and reactive engagement remained beyond the system. There was no camera link. The operator worked from directional signals and field observation alone, blind to whatever the teletank could not see. The teletank was not a disposable platform. It was a full weapon system that could be recovered, recontrolled, and redeployed. The operator's separation from the vehicle was measured not in meters of wire, but in radio range. That shift from physical cable to electromagnetic signal redefined what remote control could mean in a combat environment. The operator was no longer tethered to the weapon. The weapon moved where the signal told it to go. Number 7 refined the concept and made the guided ground vehicle a repeatable precision tool. Number 7. The German Borgward B IV, precision at a distance. Where the Goliath was expendable and the Teletank was armored, the Borgward B IV occupied a specific tactical niche, a medium-weight radio-controlled demolition carrier capable of surviving long enough to place its charge accurately before withdrawal. Entering service in 1942 and built through 3 successive marks, each improving on range, payload capacity, and transmission reliability, the BIV was operated by a controller in a companion vehicle, typically a Panzer III or Panzer IV. The BF-4 could carry approximately 450 kilograms of explosive, advance under radio guidance, drop the charge at the designated position, and then withdraw, leaving the payload to be detonated separately. This was not a one-way platform. Only the explosive was sacrificed. The vehicle returned. This made the BIV fundamentally different from the Goliath. The operator could assess placement, abort if the approach was compromised, and reposition. Operational reports from the Eastern Front document BF-4 employment against Soviet fortified positions and tank concentrations. At Kursk in 1943, Schwere Panzerabteilung 653 deployed BI-5s against defensive minefield emplacements, though results were mixed due to terrain and radio interference. The B-IV demonstrated that a radio-guided ground platform could serve a precision demolition role without being consumed in the process. The separation between operator and detonation had become controllable and repeatable. The next system left the ground entirely and placed the guidance problem in the air. Number 6. The Japanese I-GO Type B guided bomb, nicknamed the Pacific Variable. Development of air-launched guided munitions was not confined to European powers. By 1944, the Imperial Japanese Navy had produced and deployed the I-GO Ichiko Type B, a radio-controlled glide bomb designed to engage Allied shipping in the Pacific theater. The Type B was an unpowered weapon released from a carrier aircraft, typically a Mitsubishi G4M Betty bomber, at altitude. A second aircraft followed the bomb's descent and transmitted radio correction signals to control surfaces in the weapon's tail. The controlling aircraft's crew used a visual tracking system and joystick transmitter to steer the bomb onto its target. Under favorable conditions, range from release to impact extended to approximately 6 kilometers, placing the controlling aircraft outside the immediate envelope of shipboard anti-aircraft fire. The control architecture matched what Germany was applying simultaneously in the Atlantic: a trailing aircraft, a radio link, visual corrections to a gliding weapon. The system was deployed against Allied vessels in the Philippine theater during 1944. Documentation confirms at least one hit recorded during the operational period, though the program did not reach significant production scale before the war's final phase. The significance is geographic as much as technical. Japan had arrived at the same weapon concept as Germany, independently, through entirely separate engineering channels with no shared research. Multiple nations had reached the same conclusion at the same time. Wire-guided ground vehicles gave way to radio-controlled armor. Radio-controlled armor gave way to air-launched glide weapons steered from following aircraft. What began as a demolition carrier crossing a test field at the end of a cable had become a bomb adjusting its own flight path above open ocean. The progression is not coincidental. It is the result of the same tactical pressure applied across every major theater simultaneously, each nation crossing the same thresholds through independent calculation. Wire control was limited by cable length and vulnerability. Radio control extended range but required visual tracking. Television guidance would push beyond that, putting the operator's perspective inside the weapon itself. The distance between operator and target is about to expand from hundreds of meters to hundreds of kilometers. The 5 systems that remain are not tactical tools. They are strategic weapons deployed at scale, capable of striking beyond the battlefield. The threshold has already been crossed. What follows is how far it was pushed. Number 5. German Henschel HS-293, called the guided killer of ships. In August 1943, a German Dornier Du-17 released a weapon over the Bay of Biscay that struck the British sloop HMS Aigrette and sank her in minutes. It was the first combat kill ever recorded by an air-launched, radio-guided missile in operational history. The HS-293 was a powered glide bomb, 590 kilograms, fitted with a liquid fuel rocket motor that ignited immediately after release, accelerating the weapon to a speed that compressed Allied response time. Designed by engineer Herbert Wagner, the weapon was guided through the revolutionary Kell-Strasberg radio control system, with the bombardier in the releasing aircraft tracking the bomb via a tail flare and adjusting azimuth and elevation by joystick. The Kell transmitter operated on one of 18 selectable frequencies to reduce jamming risk. Release to impact range could exceed 12 kilometers. Deployed extensively against Allied shipping in the Atlantic, the Mediterranean, and the English Channel, the HS-293 sank and damaged dozens of vessels. Allied countermeasures eventually included dedicated jamming aircraft that could disrupt the Kiel-Strasbourg link, forcing German crews to rely on unaided visual tracking when jamming was active. Production exceeded 1,100 units. The HS-293 was the first radio-guided missile to demonstrate sustained operational effectiveness at sea. Not a prototype, not a field test, but a weapon in regular fleet deployment. Number 4 gave the operator a camera where the bombardier previously relied only on their eyes. Number 4, United States GB-4 television-guided bomb, the eye on the target. The HS-293 required a bombardier to track a burning flare at distance in variable visibility. The GB-4 removed that constraint entirely and replaced it with a camera lens. Developed under the Army Air Force's guided bomb programs as an evolution of the earlier GB-1 glide bomb, the GB-4 was a 1,000-pound bomb fitted with a nose-mounted television camera transmitting a live image back to a monitor aboard the releasing aircraft. The operator used that feed to steer the weapon through a radio control link, guiding the bomb from inside the aircraft without any external line of sight to the target. For the first time, the operator was not watching the weapon from outside. The operator was, in a functional sense, looking through the weapon's own eyes. Precision was now limited only by what the camera could show and how fast the operator could respond. Flare brightness, atmospheric conditions, and naked eye acuity no longer set the ceiling on guidance accuracy. Operational deployment of the GB-4 occurred late in the war, with limited combat use before the conflict's end. Image quality and operator workload remained engineering problems the program never fully solved. But the principle was unambiguous. The operator no longer needed any direct visual contact with the weapon, only contact with the image the weapon transmitted. That was the prototype of every terminal phase, camera-guided munition that followed. Number 3 achieved devastating precision in combat with a weapon that required no motor at all. On the 9th of September 1943, the Fritz X recorded its most consequential engagement. 2 weapons were released from high altitude above the Italian battleship Roma as she made for Allied ports. The first penetrated her main armored deck. The second struck near the forward ammunition magazine. Roma broke apart and sank within minutes. The question of whether a precision-guided bomb could kill a capital ship had been answered. Admiral Carlo Bergamini was among the 1,353 men lost to Dr. Max Kramer's revolutionary guidance system. The Fritz X, manufactured by Ruhrstahl AG, was not a powered weapon. It weighed 1,400 kilograms. It was an armor-piercing bomb fitted with a cruciform tail assembly and 4 spoiler-controlled fins connected to a radio receiver. Released from a Dornier Do-217 at altitude, the bomb descended along a ballistic arc, while the bombardier applied real-time corrections through the Kiel-Strasbourg system, adjusting lateral and azimuth path by spoiler deflection throughout the fall. The weapon's mass and terminal velocity gave it the penetration capability to pass through the armored deck of a capital ship before detonating internally. The same campaign also struck and severely damaged the British battleship HMS Warspite and the American cruiser USS Savannah during the Battle of Salerno, removing them from the war for months of repair. In a single operational period, a radio-guided bomb had neutralized vessels representing decades of naval investment. What the aviation establishment had doubted was now confirmed. A precision-guided weapon could reliably hit a maneuvering ship-sized target under combat conditions. The Fritz X proved guidance could kill a capital ship. Number 2 asked a different question, whether a guided aircraft could replace a guided bomb entirely. By the summer of 1944, the Allied air campaign was encountering a specific structural problem. Reinforced German targets, V-weapon launch bunkers, submarine pens, and hardened industrial facilities were built with meters of concrete, that conventional bombing could not reliably penetrate. The solution proposed under Operation Aphrodite for the Army Air Forces and Operation Anvil for the Navy was to strip war-weary B-17 and B-24 bombers to their airframes, load them with approximately 18,000 pounds of Torpex explosive, and fly them into hardened structures under remote control. The procedure required a pilot to take off in the aircraft and arm the explosive payload, then parachute clear before control transferred to a companion aircraft flying in formation. From that point, the companion aircraft's operator guided the now pilotless bomber through a radio control link while a nose-mounted television camera, applying the same principle as the GB-4, transmitted the approach image back to the operator. What had been demonstrated with a 1,000-pound bomb was now applied to a fully loaded heavy aircraft. The GB-4's camera was the operator's eyes. The radio link was the pilot's hands. The aircraft itself had become the weapon. Individual missions encountered serious engineering failures in the radio control handoff sequence. Lieutenant Joseph Kennedy Jr. was killed when his aircraft detonated before transfer of control was completed, an engineering failure in a program that had nonetheless already crossed a structural threshold. A crewed aircraft had been redesignated as a remotely piloted weapons system, guided by an operator who was never aboard. Aphrodite converted existing aircraft into weapons. Number 1 was never anything else. Number 1. German V-1 flying bomb, the first autonomous weapon. On the 13th of June, 1944, 7 days after the Normandy landings, the first Fieseler Phi 103 crossed the English Channel and struck London. It had no radio link, no camera feed, no operator in a companion aircraft, no wire trailing behind it. It flew itself. The progression to this point had been exact. The Fritz X needed a bombardier with a joystick in the releasing aircraft. Aphrodite needed a pilot, a parachute, a radio handoff, and a second crew in a chase aircraft. The V-1 needed a launch crew and then nothing more. The moment it left the ramp, no correction was possible, no abort was available, and no guidance link existed to be jammed or severed. Navigation was managed by a gyroscopic autopilot, maintaining altitude and heading without external input. A vane counter in the nose tracked air distance traveled, and when the preset count was reached, the fuel cutoff triggered, the engine stopped, and the weapon entered its terminal dive. The operator's involvement ended at the moment of launch. This was not remote control. This was autonomous flight with a preset terminal objective, effectively the world's first operational cruise missile. Over 9,000 V-1s were fired at Britain, with the majority targeted on London. More than 2,400 struck the city. Additional thousands were launched at Antwerp, Liège, and Allied logistics targets on the continent. Defenses adapted over the course of the campaign. Anti-aircraft gun belts were repositioned along the coast to engage the weapons before they reached populated areas. Balloon barrages forced them lower, and high-speed fighters developed techniques for tipping them from the air. But the strategic fact the V-1 established could not be reversed. A weapon could now take off, navigate, and detonate without a human operator performing a single action after launch. Every wire paid out behind a Goliath, every radio signal transmitted to a Teletank, every television image relayed back from a GB-4. The entire trajectory of this countdown pointed here. At the point of impact, the human chain had ended before the weapon left the ground. In 1945, the war ended. The developmental arc it produced did not. From a wire-guided demolition carrier on a French test range in 1939, to an autonomous cruise weapon crossing the English Channel in 1944, the progression was continuous, multinational, and driven by the same operational pressure applied across every theater simultaneously. The Goliath required a man with a joystick within cable distance of the target. The V-1 required a man with a launch checklist. Between those 2 points, the wire became a radio signal. The radio signal became a television image, and the television image disappeared entirely. The technological foundations of modern unmanned warfare were not established after 1945. They were proven under combat conditions before it ended, at every scale from a 60-kilogram demolition vehicle to a 9,000-unit autonomous strike campaign. What followed in the decades after the war was not invention, it was refinement.